Hello friends, my name is Vijay Kumar and we are studying refrigeration and air conditioning. In the last video, we have seen some properties of refrigerant, thermodynamic properties. In that video, we have seen four properties: critical temperature, specific heat, then enthalpy of vaporization, after that pressure ratio. Now, we will see specific volume at the inlet to the compressor. Fifth property, specific volume at the inlet of compressor. You know very well what is the specific volume. Specific volume is volume per unit mass flow rate or work per unit mass. This is the volume. If I say specific volume is volume per unit mass, that means this volume is going to the, if this is the TS curve, you know very well this is compressor 1, 2. So specific volume at this inlet at point 1, that means V1, small V1. If this volume is very high, in that case compressor size will also be very high, because compressor has to handle very large volume of vapor. So it is desirable that the specific volume at the inlet of a compressor should be low. So if I say that specific volume V1, that means specific volume at the inlet of the compressor should be low, because compressor size increase are. Now let's see the next property, freezing point. The freezing point property. Here are some examples of refrigerant like R22, R11, NX3, R134A. The freezing point of R22 is 160.5, minus 160.5. R11 minus 157.4. NS3, that means ammonia, minus 77.3. R134A minus 101.3. What is the meaning of that freezing point? Suppose this is the point or temperature at which refrigerant will go into the evaporator. That means the temperature of evaporator is decreasing from 3 to 4. If the freezing point is here, suppose if I am using R22 and freezing point is here, that means minus 160.5. And process has to occur from 3 to 4 up to this point, 4. That means this refrigerant will freeze at this point only. That means freeze means it will become ice. It will become in solid form. So heat transfer in the process in evaporator will not take place. So the freezing point should be very, very low, as much as possible. If freezing point is here, sometimes if I draw the freezing point here, then it is okay, no issue, because above this a process will occur in evaporator and heat transfer will take place. Okay, so the freezing point should be as low as possible. Now see the left Next property, COP. Let's see the next property, COP. That means coefficient of performance. You know very well what is COP. COP is the ratio of refrigeration effect divided by power work input. In this case, what is the refrigeration effect? If I convert COP in refrigeration capacity form, RC divided by power input, that means multiplied by mass flow rate. I have already explained all these things. This will become RC and this will become power input. So if I write mass flow rate into RE, that means H1 minus H4, this is power input. See here, this is the H1 minus H4, this is the enthalpy of vaporization. For maximum COP, enthalpy of vaporization should be more. If enthalpy of vaporization is more, for same RC, mass flow rate will be less, size of the system will be low. So, what is the desirable property of a refrigerant in case of coefficient of performance? That means COP should be very, very high. And it will be high if enthalpy of vaporization is high. For same RC. Okay. Now, there is one exception. There is one exception. The exception is that ammonia has high enthalpy of vaporization. That means very high. If I say very high enthalpy of vaporization. But this will not improve the COP. This will not improve the COP. Because if I am using this ammonia in this system, then work input to the compressor will be very high. So if work input is very high and enthalpy of vaporization is very high, so we cannot predict that the COP is very high or less. So ammonia is the exception for this case. Okay, now let's see the next property, compressor discharge temperature. Let's see the next property, compressor discharge temperature. What is that temperature? 1 to 2 is the process which is going on in compressor. That means this point. This is the compressor discharge temperature. That means P2. If I say P2. If this temperature is high, suppose the process is going up to this point. This point is 2 dash. That means P2 dash. In this case, what will happen? In this case, overheating will happen in compressor. Overheating. Overheating will take place in compressor. So, due to very high discharge temperature from the compressor, overheating will take place in compressor. So, you have seen the window AC in your house or split AC. What is the type of cooling in the outdoor unit or rear side of a window AC? That is air cooled. Because the air discharge temperature of that compressor is low. Not that much low, but it is less. But if the compressor discharge temperature is very high, like in this case also suppose ammonia, if I am using ammonia, and the compressor discharge temperature for ammonia, this is 120 degrees Celsius. To cool the refrigerant from this point to this point, we have to use water cooling. Water cooling of compressor. Okay. In our window AC and split AC, that is air cooled compressor. So, friends, we have seen all properties of thermodynamic class. That means thermodynamic properties we have seen. Now let's see the chemical property of a refrigerant. Now let's see the chemical properties of a refrigerant. These are the chemical properties. I have already shown these properties: toxicity, flammability, action with oil, and action with material of construction. Let's see one by one. Toxicity. You know very well that if a window AC or split AC. Now let's see the chemical properties of a refrigerant. These are the chemical properties: toxicity, flammability, action with oil, and action with material of construction. Let's see one by one. Toxicity. Toxicity means if a window AC or split AC have a refrigerant which is toxic. In that case, if pipe is leakage or the refrigerant will leak out from the system or from the AC, it will go into the environment. So the toxic effect of a refrigerant will have adverse effect on the environment, on the living things. Okay, so the refrigerant should not be toxic. It means refrigerant should not be toxic. The second property, flammability. Now let's see the flammability property of a refrigerant. Flammability means the refrigerant, if leaks out from the window AC or a split AC or any refrigerating system, that will catch fire, that will catch flame. So there is a fire hazard. If a refrigerant is having the property is flammable. Okay, so the refrigerant should not be flammable. Refrigerant should not be flammable. Here we see the example again, ammonia. Ammonia is very cheap, but we cannot use ammonia in our domestic refrigerator. If I say in domestic refrigerator, what we call fridge, in our house we call fridge now. In domestic refrigerator we cannot use ammonia because ammonia is toxic as well as flammable. So before choosing any refrigerant for a system, we have to see all the properties like thermodynamic properties which I have explained, and toxicity and flammability, and other property which will I explain later. Okay, so let's see the next property, action with oil. Now let's see the next chemical property of refrigerant, action with oil. What is the meaning of this? You know, in compressor there are moving parts. So for proper lubrication we are using oil in compressor. What is the meaning of action with oil? It means the refrigerant which is coming from the evaporator and it is going to the compressor. After the compressor, the refrigerant will go to the condenser and it again will come to the evaporator. After going out from the compressor, refrigerant will take oil. Refrigerant will carry oil. So after compressor, refrigerant and oil both will go to the condenser, then expansion valve, then evaporator. In evaporator, what will happen? In evaporator, the refrigerant will evaporate because it will take heat from the storage space, and that refrigerant will again go to the compressor. But what will happen on oil? In this case, refrigerant plus oil. So in this case, what will happen? Oil will accumulate. Oil will accumulate. Here oil will accumulate. The accumulation of oil will result in reduction of heat transfer. Reduction of heat transfer. That means less amount of heat the evaporator will take from the storage space. If heat transfer is less, that means refrigeration effect is less. If R is less, then COP is less. Now you have seen that the effect of oil in this system. Effect of oil in this system is very high. If oil accumulates in the evaporator, then COP of that system is very low, because there is a less heat transfer in the evaporator. Now see that the refrigerant and oil, there is a two type of mixture. There are three type of mixture. Three case if I say. Case 1, refrigerant not miscible with oil. That means there is no mixture of oil and refrigerant. Case 2, refrigerant miscible with oil. That means there is a proper mixture of oil and refrigerant. There is a third case, refrigerant partial miscible with oil. There is a partial mixture. Partial means somewhat mixing and somewhat is separating. Somewhere oil is separating and somewhat mixing, complete mixing. So there is a partial mixing. Let's see one by one. Case 1, case 2 and case 3. For case 1, refrigerant not miscible with oil. If refrigerant is not mixable or miscible with oil, then refrigerant will go to the condenser. Here I will take, what I will take? Here I will take oil separator. Oil separator. So in this case 1, oil separator will help. It will collect oil in oil separator, then refrigerant will go to the condenser. Only refrigerant will flow in the system. So with the help of oil separator, oil will collect and this oil will again go to the compressor. This is for the case 1. Now for case 2, refrigerant miscible with oil. In this case, what will happen? The refrigerant and oil will go in the system because of proper mixing and complete mixing. Because of complete mixing and complete miscibility of oil and refrigerant. Here also oil and refrigerant will go. Here oil and refrigerant. Here oil and refrigerant. In evaporator also, refrigerant will take oil to the compressor. In this case also, refrigerant and oil both will go. Refrigerant and oil both will go to the compressor. So there is no effect on the heat transfer. So in case 1 and in case 2, there is no effect on heat transfer in evaporator. But the culprit is case number 3. You have to be very careful about the case number 3. Case number 3 is refrigerant partial miscible with oil, which I have explained already. Those refrigerants which are partial miscible with oil, in that case there is a problem. And the problem I have already explained, that oil will accumulate in the evaporator and refrigerant will go to the compressor. So in this case 3, refrigerant partial miscible with oil. How to protect or how to recover this case? In this case, you have to use synthetic oil. In this case, you have to use synthetic oil. By using synthetic oil, there is no mixing of refrigerant and oil. So friends, we have seen the action with oil with three cases. Now I'll tell you what are the refrigerant in this case, what are the refrigerant in this case, and what are the refrigerant in case 3. So case 1, in case 1 ammonia is there, ammonia and CO2. These refrigerants are not miscible with oil. In case 2, R11 and R12, the refrigerant are miscible with oil, so no problem. In case 3, R22, if I am using R22, in that case refrigerant has partial miscibility with the oil, so there is an effect on the coefficient of performance of the system. So in this case, synthetic oil in the compressor will be used. And mostly R22 is the gas which we are using in the window AC and split AC. So if we are using R22, we have to use synthetic oil. Okay. Now we have covered 3 properties. Now let's see the next property, action with material of construction. Now let's see the next property, action with material of construction. In this case, material of construction means the outdoor unit, that means condenser and evaporator. Condenser and evaporator coils are there. In that coils, the coils are made up of copper or aluminum. If we are using the copper, or we have made the system with the copper piping, and I am using ammonia, then ammonia will attack copper. Meaning of attack is that it will corrode copper. It will damage the copper. So if I am using ammonia, I have to use wrought iron or steel for a metal for the construction of the system. Similarly, if I am using ferron attacks aluminium. That means ferron damages the material which are made up of aluminium. So in that case, I have to make the system, I have to construct the system with copper if I am using ferron. So friends, we have seen the chemical properties, toxicity, flammability, action with oil, action with material of construction. Now let's see the physical property of a refrigerant. Now let's see the property viscosity. It is a physical property of refrigerant. Viscosity means the thickness of a refrigerant. If refrigerant is very thick, then the refrigerant will not flow easily in the tubes or in the evaporator tubes and condenser tubes. So the refrigerant should not be viscous. Refrigerant should not be viscous. Refrigerant should not be viscous. Because if it is viscous, then there is a problem of flow in the system. Now let's see the next property, leak detection. Now let's see the property leak detection. Friends, the refrigerant should not leak out from the system. This is the ultimate criteria, this is the first criteria, that refrigerant should not leak out. If refrigerant is leaking from the system, then automatically the performance of the system will go down. So our first priority is that the refrigerant should not leak out. If refrigerant is leaking out from the system, then the leak detection should be very simple. Leak detection should be very simple. So I have taken 2 examples. Suppose in a system I am using ferron as a refrigerant. If ferron is leaking from the system, Then we use the halide torch method. Halide torch method for detection of leaking of pheromone. If I am using halide torch method, in that case, the blue light will convert into bluish green. If this condition is there, that means pheromone is leaking out from the system. If it is blue color, then there is no leaking. There is no leaking or no leakage from the system. Okay. Now, second example, if ammonia I am using as a refrigerant and that ammonia is leaking from the system, then sulfur split method is used to detect the leakage of ammonia. In that case, white fumes of ammonia sulfide are formed. White fume of ammonia sulfide are formed. If this condition is there, that means ammonia is leaking from the system. So friends, we have covered all the desirable properties of refrigerant in this video and in the previous video. Thanks for watching and have a good day.